In this video, we're going to be doing calculus, derivatives in particular, from the question paper of the Gauteng 2025 June question paper. So you are more than welcome to pause the video, attempt the problem by yourself, and then check if your answers are correct. So the first question, which is Q1, Q7 by the way, it states, given f of x is equals to 3 over x, determine the derivative of f of x from the first principle. Now, for the first principle formula, we use this formula, which is f of x, or the derivative of f of x, is equals to the lim, which is the limit as h approaches 0, f x h minus f of x over h. Now this is the formula we use to derive. This is not a double integral. Okay. Now, I usually advise my students, before attempting to solve this, solve it using the rules to see if ever your answer will correlate with the one that you find in the first principle. For instance, in this case, we're going to times this answer by -1, where it's going to be -3x, and then subtract 1, then it's going to be -2, which the final answer should give us what? Should give us -3 over x squared, right? So our final answer should be -3 over x squared. Let me try and write it properly. -3 over x squared. So let's begin. Now the first step, I would say to them, sub x plus h into f of x, right? So they usually substitute. It's going to be 3 over x plus h, right? Then you're done. There's nothing else. You can simplify it. It's not a square. It's, it's just a basic problem, no function. So from there on, we're going to say the lim as h approaches 0, 3 over x plus h, which is the f of h plus x plus h, I mean, and you want to subtract 3 over x divided by h. So from here on, what would happen is you try to fix the denominator, not fix it, but rather find the common denominator, of which it is going to be x plus h multiplied by x. Now remember that this is 3, by the way, right? So this is going to be 3x minus 3x plus, it's going to be minus 3h. The reason why I say minus 3h is because of this minus, right? So from here on, what would happen? This is a different color, so this and this would cancel each other, and I'm left with what? I'm left with 1 over h. Don't forget about it. And I'm left with 3h, negative 3h. It's going to be negative 3h, and it's going to be negative 3h over x, right, multiplied by 1 over h, right? Good. So from here on, what would happen? We would then cancel this with this, and after cancelling it, we would be left with minus 3. The lim as h approaches 0 of minus 3 over x plus h, right? Now for those who are wondering what happens now, we are going to use the limit, input the 0 here, it's going to be minus 3 over x plus 0. Now remember that x times x is going to be x squared, if it's going to be minus 3 over x squared. This is our final answer. Is it similar to this one? Yes, it is similar. This means we are correct. Now, even though sometimes they usually don't find the correct answer, they usually do it again. You should also. Now we're done with the first question. Now moving to 7.2. This one, it asks us to find the derivative of this the cube root of x squared minus the square root. Okay, let me just not say the square root, but let me read it out the way it is. Minus x to the power of minus 3 over 2 over the square root of x, right? So what would happen first is you're going to write the dx squared, right? Good. So then after doing this, many of you or many students, when they do this, they would they would forget that this is the same denominator, right? They will try to simplify on the top the numerator, which is quite wrong because you're gonna take some time, So you're gonna firstly put each and every variable on top over its own denominator, which is the square root of x. It's common, by the way. What is square root of x? Don't forget this. Now after this, we are then going to simplify this or write it in the form of an exponent. So it's going to be 2 over 3 over x 1 over 2 minus 3 over 2 over x 1 over 2. Almost wrote negative. So from here on, we would then subtract, right? Since this is the same base, so we can then subtract since exponent laws. So 2 over 3 minus 1 over 2 is supposed to give you 1 over 6. So this means here it's going to be 1 over 6 minus this one, which is minus 3 over 2 minus 1 over 2, of which our answer here is x minus 2. From here on, we can start to derive it and say 1 over 2, 1 over 6, I mean, x, subtract 1 here, and you're going to have minus 5 over 6. Then multiply this by negative 2 multiplied by negative x. It's going to be plus 2x. Subtract it, it's going to be minus 3. This is our final answer. Usually I would honestly tell my students, please leave it in a positive exponent. So don't leave it like this as a negative. You can just put it in like 1 over 6x minus 5 over 6. It's going to be plus 5 over 6. That's 2 over x cubed. This one. Just in case if the examiner next time asks us to put it in a positive exponent. Alright. Now, after doing this, you're done. Let's move to 7.2. Of which this one requests us to find the derivative of xy minus y, which is equals to x squared minus 1. Okay. So here, the only thing that will confuse many students is, what is happening? Where is the y? The y's are here, but like always, we have to find our answer, right? So it's xy minus y, which is x squared minus 1. So the common thing on this side, right? Since they said dy over dx, there you have to derive y with respect to x. So common one, it's y here. You're left with this, right? Then from here on, you divide both sides by x minus 1, which is going to be y, which is equals to x squared minus 1 over x minus 1. Then now it's simple, everyone can solve it, which is quite fascinating. From here on, you know that you can derive this. Actually, you can factorize it, and it's going to be not derive it, factorize it. The reason why I say so is so we can try to make it much more simple and simple and simple, because yes, you can derive it while it's like this, but then it would take you a long time. So we always like simple things, you know. And y is equals to x plus 1. Therefore, we can derive it and say dy with respect to dx. The derivative of dy with respect to dx, it's 1. Because this one is going to be 0 and this one is going to be 1. Now, in some cases, they may try to trick you, but it's not common, but then they may say derive this if x, x squared plus 1, if y is equals to x squared plus 1. Now you see that there's no z, therefore your answer would be 0, because in this case we take x as a common, as a number, so yeah, keep a heads up for that one, because usually you should take note of this. They may maybe say y and z, or y and y, put it and say dz over dy, and then you know that, okay, in this case, this one, the answer is going to be x minus, what is this? This is a constant, so it's just going to be 1. This is 0, by the way, in respect to 1. Okay, yeah, it's a 1. I thought it was z. Sorry, yeah. That's how it's mostly not common, but it could happen. It's just a heads up. Cool. Now let's move on to 7.3. We're done with our derivatives. We scored all of those marks. Now we have them. 7.3. It's a quite interesting one. One line, because this is the calculus graph. The graphs whereby we use them to explain or to draw cubic functions. Now, there's something quite good about these graphs, which is the fact that it's part of calculus, and calculus itself, it's also integrated into physics, right? So, yeah. So 7.3.1, they say the gradient, or they say show that a is equals to 2 and b is equals to 3, and then they also tell you that the gradient of the tangent to the function represented by f of x, it's equals to x cubed plus bx squared at the point 1 and 5 is 12. So they've told us the gradient at that point of 1 and 5. Now we have to find what? We have to find the values of a and b. Now it shouldn't be quite hard. But then the only problem is, where do we start? Quite simply, the first step that we're going to do is we're going to first derive this thing. Let's derive it. So it's f of x, which is equals to a x cubed plus bx squared. Now we're going to derive it. Right? 3ax squared plus 2bx. Good. Now after deriving it, remember they said the x value at the gradient 12 is 1, right? Here it is. This is the one. The gradient is 12. So this means this thing I can write 12 and also use the x value, right? Because remember I said at the point of 1 is to 5 is 12. That's the gradient. So you can then just do the math, and you should find 3a plus 2b. Cool. Now after doing this, what should we do? This becomes the equation 1. Why? Because of two variables which are known, simultaneous. We then going to go back to our original function and say, how about we input the value of 1 and 5? Now f of x is equals to a bx good. By the way, anyone could have started any way that they like. You're more than welcome to start the way anyway. You can solve it using multiple methods that there are. So it's going to be 5, which is equals to a1 cubed plus b1 squared. And we're going to have 5. A, if it was a negative, it was going to be a negative a, but then it's positive. So let's save it. And b, right? So this is our second equation. Now we're going to create our third equation, which is going to be 5 minus a, which is equals to b. This is our third equation. Now sub 3 into 1. Let's do that. It's going to be 12 is equals to 3a plus 2, 5 minus a, right? And from here on, we're going to say 12 is equals to 3a plus 10. 5 times 2, it's 10, minus 2a. Take the like terms, group them together, and you should have a. Then your a should be what? Be 2. So therefore my a is 2. Now since I found my a, I can then go back to this one, equation 3, and say b is equals to 5 minus 2. Now b is going to be what? B is going to be 3. Do they look similar? Yes. So that's how it is. That's how you solve it. It's quite simply that way. You have to understand what they mean and understand that the first derivative it's the gradient of the tangent. When you derive it twice, now you're looking for the concavity of that function of the cubic function, right? Good. Now let's look at the last one, which is 7.3.2. Now 7.3.2, it states calculate the coordinates of the point on the curve where the tangent to the curve is parallel to the x-axis. Now they want, let's say, to show you, they want, this is the tangent, the values at which, these values here, the coordinates of the points on the curve at which the tangent is parallel to this, to the x-axis, right? That's all that they want. They just want the turning points. So yeah, let's continue now. Let me erase this. All right. Good. Now let's do it. Now, for us to find those points, we first have to derive. So since we know that our graph, or our function, is equals to 2x cubed plus 3x squared, our cubic function, we can then derive it. The reason why I'm deriving it is because the tangent, in order to find their gradient, is what we have to derive first. That's why I'm considering that. So then it's going to be 6x squared plus 6x, right? Now after you found this, remember that the tangent at that point, they equal to what? To 0, right? Right? They equal to 0. And the function at the x-axis is equal to what? To 0. Why? Because when we look for the intercept, we let y equal to what? To 0. Good. So from there on, we can do the maths. And use this one. Let's use this one. This one, we're going to use it at the later stage. Let me just erase it for now. So, since we know that the turning points, it's the maximum point of which it's 0, the y value. So it's going to be x squared plus x. I divided both sides by 6, which is going to be 0. From there on, factorize the x, which I will have x plus 1, which is equals to 0. From there on, equate both sides, right, both values to 0 to find your answer to be this. Now remember when I said we're going to use this one at the end. This is the point. We're going to use it at. I said it's equals to 0 because we let y equal to 0. And the maximum point is 0. That's why I put this one as 0. So we're then going to say 2 0 cubed plus 3 0 squared, which is equals to 0, right? The answer is just 0 because what's this? 2 cubed, 0 cubed is 0, 0 squared is 0, so it makes no sense, right? So it's also not necessary for you to write this side also because we have the x values, yeah. But if you like, you actually don't do it, but then yeah, it's fine. And from here on, we then gonna input this one, minus 1, then 2 minus 1 cubed plus 3 minus 1 squared, and we should have what? We should have 1. So the coordinates at which, or the points at which the curve is parallel to the x-axis is what? 0 and what? And 0 and -1 and 1. Yeah, so that's how you do it. By the way, just to confirm with you, you don't need to write the equal sign here. You don't need to write that 0 because we're looking for the y value. Yeah, but anyways, that's how we do the calculus for the grade 12 Gauteng question paper 2025 June. I hope you enjoyed it, and see you next time.